Let's continue our A Work in Progress series, talking now about error handling when first starting up the app. In previous videos, I've introduced to you a framework needs to be able to set up the app ready to be run by the user, as well as error handling. Two critical aspects of a framework that I didn't find in the current solutions offered. The MVC pattern does just that. Now it provides you with a means to set up your app with all the asynchronous operations necessary. Everything from opening up databases to logging in to Firebase, for example, or what have you. Let's watch this framework handle a situation where the app crashes, where the app fails to start up properly. I've put an explicit bug in this app, preventing it from accessing the Firebase remote configuration feature by calling on null. As I've done before, this no such method error was demonstrated in a previous video. I'm doing it again, but this time when you're actually starting up the application. So let's do that. I'm going to go in here, hit debug. I do have a number of breakpoints that I want to stop and demonstrate this application. First and foremost, we'll just run through it. We'll ignore the breakpoints. We'll just continue on and see how it behaves. So here's the breakpoint. Let's ignore that for now and just simply carry on with this and see what happens. I'm going to show you exactly how this sets up error handling, what happens when it first starts up, and of course in this case what happens when an error is invoked. So the no such method error has been triggered. In this case, my Firebase remote configuration is not set up properly. I've simply commented out that instantiation. So calling this method now will call on null, which is a no-no. In this routine here, this init async method, it itself responsible for the Firebase remote configuration, for logging the user in, for even opening up, calling on yet another controller to open up a database. Let's take a look. And here we initiate the model aspect of the MVC design pattern and opening up a database and doing a query. If we go back to the superclass, right now you can see that this method is dedicated to initializing any time-consuming operations at the beginning. And there will be a number of time-consuming operations typically found in an app, so a framework should consider it. So this framework does consider it. It utilizes the Flutter's own Future Builder widget, calling of type Boolean, initially set to false. When all the operations are completed, it's set to true. In this init, there's a number of operations involved. We'll go through that shortly. But more importantly, what happens when an error occurs? You've got to account for it. It will happen with one of your apps. So a typical future builder, it generates a snapshot, as you know, and there'll be instances where that snapshot will indicate an error, and that's what will happen here. When the builder is called, it tests for the Boolean future value coming from this name parameter. It goes through into the init and then goes through this function here, passing in the snapshot, we know that it tests for done. So when the snapshot connection state is done, and it has data, and that data is true, in this case a Boolean value, we press on. And the home screen is displayed. The home screen defined by your app. And that home screen is found here, in this case, in the app state object. State object, in other words. So let's go back. So here, this goes through a number of times. If it's not done, in other words, that connection state is still at waiting. And if it is waiting, then you'll see circular object spinning in the middle of your screen. Of course, there's also a loading feature. You can actually present a loading screen. If it's not a loading screen, depending on the platform, you're going to have a circular indicator in the center of your screen. Otherwise, more often than not, when the connection is done, you're going to have your home screen appear. But there will be times when an error occurs, like so. And that's what's happened here. So it's now falling out of the framework. It's falling out of your code. It is going now to fall back to something that can handle the error. In this case, it's falling back to the snapshot object, which will be assigned the error indicator. So what we had was this view had called one of its controllers, and one of those controllers, as you know, had an error. Pretty blatant one at that. So we keep falling out. Now we're falling back out. So what's going to happen? We're going to fall out of this init async, and we're going to fall into here, into this builder, this anonymous function. It's going to take in the snapshot. So let's go there. And we're going to find ourselves right here. The snapshot has an error. It's true. So now I take in that snapshot error as a dynamic value, because the dynamic value can be passed into this named parameter called exception. I want to generate a Flutter error details object. It's dynamic, and I'm free to test a dynamic variable. If the exception is error, then I can pass in a stack trace, because this parameter, this name parameter, can take in null. Notice the question mark. So it can be null. What I'm doing here, of course, is taking advantage of how Flutter itself, the framework itself, handles errors, and consequently, if there is an error, it generates a Flutter error details object. Here I'm specifying which library file, which Dart file had the error. I'm giving it a user-friendly, a human-friendly message while getting ready in the future builders async. Quite frankly, we can also put in international localization here. You have the means, and put in a number of languages. So it generates the details. Now what? I've offered the developers using this framework to handle it themselves. The view, in this case called the app state, The view also provides you a means to handle errors in the asynchronous operations in the form of an anonymous function. So in async error, you got to return true if you handle the error properly. Else return false. Let's go back here. This is not null. It's going to call that value. In other words, call this method. Go in there. This method checks to see if its controller can handle it, giving the developer every opportunity to catch their own errors, to handle their errors. So what is this value? Well, this is this. Here is the app state, the view, the app view, the view of the MVC design pattern, the view at the app level. Here's the view at the home level. Here's the controller at the app level, so I call that the app controller, and it too is called upon to see if it can properly handle the error that occurred during an asynchronous operation, during these asynchronous operation. That just happens every time you start up an app with this MVC framework. There is always a future builder with some asynchronous operations. If you don't have any, then ignore this. Simply don't put anything in to the asynchronous methods that are provided you. But more often than not, you're going to be opening up databases and setting up internet connections. Well then, if there is a problem, if there is an error, you may have to close those connections. You've got to clean up after yourself. This provides you a means to do so. So let's step into here. As it happens, this is the parent class, and it's not implementing anything. You can supply an error handling routine if something goes wrong in the corresponding init async routine. Since we haven't overridden this method, it provides the default behavior, which is to return false. So it's not handled. If it returns null, in other words, it wasn't even defined, I even make sure the framework doesn't blow up. It returns false otherwise. If it's null, it returns false. In this case, it's not implemented, it returns false. The handle will be false. So we go here, since it's not handled, which is true, and this method, this anonymous method, is not null, we find ourselves now in here. Notice I have it in a try-catch. Dare not have an error within the error handler. So if for some reason blows up, this is false. Let's do that. Let's go in there. For demonstration purposes, I implemented it. Of course, it returns false. Get out of there. So it hasn't been handled. False. So the developer has failed to handle that asynchronous operation. So what do? We turn to the app. The app will handle it. It too has its own routine. If it's not handled yet, we handle it. Take care of things for you if we must. What we do as it happens, I take in the snapshot. In this current version, I take it in anyway, generate yet another Flutter errors details object, and I pass it to our own error routine. So here is the framework's, the MVC framework's own error handler. It finds its own handler if there is one. Otherwise, it just falls back to the Flutter framework's own error handler, which is simply to dump it to the console. In this case, we have our own handler, so let's see what that does. Here's the handler that's offered by the framework. It's got some code in there, of course, again, its own way of preventing an infinite loop. We can't have errors within errors. Here is the handler defined, whatever that is. Let's find out what that is. If you're familiar with my past videos, you know I use Crush Linux to report my errors to Firebase, and that's what we've done here. This was set up at the run app function. You, of course, are free to set up your own error handler, your own custom error handler, a third-party error handler, as in this case, or the default, which will be just simply to dump it to the console. As it happens, before it records it to Firebase, it too dumps it to the console. So we've done that. Let's go to the console now. Sure enough, there it is. The method init async was called on null. Now what? Your screen has to be addressed now. Your app cannot continue. Your home widget was to be displayed, but now it cannot. It cannot proceed, so we display as usual. When a widget, the building of a widget fails, you are traditionally presented with the red screen. So let's do that again. Let's present that red screen, and that's what this does. Go in here again, then try catch. Make sure that if this errors for some reason, we're not certain, you may have defined it. You see, the developer again can define their own error widget builder. If so, and it fails, we fall back to our default, which again is still yet another widget builder, a red screen presenting the error. But at least it catches any problems with the error handling itself. As it happens in this demo, this is already defined in here. So when we go to our screen, there we are. Not pretty. The developer, you have the option of putting in a very nice screen, not even show any error message. Maybe show a user-friendly error message saying that your developers are on the problem. You may not even provide a stack trace. I've provided my own stack trace. This is traditionally, if the Flutter framework encounters a widget error, building a widget, you're only given the error message itself. I didn't like that. I want to see more, so I have the error message and at least 4 levels of the stack trace to give me some indication where the problem was. So in this case, I can see at a glance that this file here, working memory app, at line 88 was the issue. So let's do that. Let's go to working memory app, line 88. Oh, it's a little different. Why is that different now? Did I change something? I must have changed something while we were presenting this. I changed the value there, the number. It's not exactly line 88. We're going to run it again, but we're going to walk through it a little further, get some further details. Start it up. I have a number of breakpoints that I want to discuss, showing where, in fact, I put in the error handling. Here's the main. We are now going through the IDE here. We have our own stack trace here. Now it's creating a new app state widget. We're now going into the super, into the parent. And as you can see, again, the framework is worried about error handling right at the very beginning. In the app stateful widget itself, we initiate the error handler. So let's go in there. There's the error handler. this is the app. That was the app object there. Then we go through the app object, and in the app object, right at its constructor, we start up the error handler. That error handler has its own constructor. As you can see, it's a factory constructor. So we're following a singleton design pattern in this case. There's only one instance of this app error handler. But is this code implying you can call it again and again and again? Because this won't be initiated again. This is a static variable. Once instantiated and assigned, can't be assigned again. It simply returns the original instance that was first created. But as you would see, it does allow you to provide handlers even after the instantiation. I want to walk through this a little bit. So when you first instantiate, it records the current error handler, the current error builder, and it assigns the builder. At the start, you define the one that I conceived. I didn't like just simply showing a red screen with the error message. I wanted to see a bit of the stack trace. And that's what this does. Error display widget. And it's assigned right then and there within the private constructor. Further in this private constructor, I define the error handler. I've already saved the old one, and I'll return to the old one when this is disposed, when the app terminates. But right here and now, I set up the error handler. Right there. I even record it, keep a reference to it so I can access it again. So that's very important. So I define a builder that I prefer right away. So let's run this. Continue to run that. It stopped again. It's called the error handler again. This time it's called within the run app. So right then and there you can guess that this isn't the run app you're familiar with. In this case, it's part of the demo app. In the demo app, I want to incorporate Crash Linux and use that, but I didn't want any developers really to know. There it is right there. That is coming from this Dart file, which I call an export file. This is a common practice used by developers in using Flutter and Dart applications. That's worthy of a whole series of its own videos. We'll get to that eventually. But right now, okay, let's do this. We are in the run app. We're in the main method. Calls run app method. After instantiating the app stateful widget, it now calls this method. Well, this method is found here. And this is found in the working memory app. It's a controller. Again, it's a system event. It should be code found in the controller. It's at the app level. It's not at the home level. The MVC approach actually encourages you to emulate the model, view, and controller throughout every aspect of your app. So the app has its own controller, view, at the app level, and at the home level, it has its own controller, model, and view. So I can tell at a glance that this should be found right here. This run app is unique. It offers you not only the app itself, of course, a required parameter, but name parameters follow. You can define your own handlers if you want. And in this case, I have. If they're not defined already, I initialize the Crash Linux. And I enable it to report the data sent to Firebase. And then I call this run app. Well, what's this? Well, this is yet another instance of run app. This is found within the MVC controller under controller app. Again, giving the developer every opportunity. It's paramount to handle your errors. Paramount to handle your errors. Let's have the user given every opportunity to define the error handler. However, it's a very powerful tool. You've got to have some control over who gets to assign a new handler. Let's go back to the error handler itself. Here's the app's error handler. Notice this one parameter called allow reset. I'm going to change that name to something else more applicable. But right now this is set to true. That means that allows you to call this again and reset the handler values. If it's false, once you're not allowed to reset the handlers, it can't be reversed. Once it's false, then no. You can't continue on and reset the values. But here, it's set to true. However, it's false. Because at the run app, when you run this particular method, the allow reset is always set to false. It's always assumed that you want to just use these handlers and these handlers alone. I just want to use Crash Linux. I don't want any subsequent calls to the error handler to change my settings. So once this is set and this passes false, that's it. Can't change anything else. So it goes in here. It's going to change some values. Reset. Reset. Builder's not changed, so it's still using the one that I first assigned. The reset's true. So if you ever use this in your own app, you can call this. This is a static method, and you can watch for a Boolean value, true or false, to tell you whether you're successfully able to just change the values or not. But here's the magic. Because I've assigned false, because this is false, this static variable, this static private variable is now false. So it's done. A person can instantiate that error handler now again and again, all they want, and throw as many handlers as they wish. But that's it. You won't be able to change anything else any further. You've got to have some control, particularly when it comes to controlling how errors are handled. So that's done. Again, inside this run app offered by my MVC App Framework, it provides error handling for errors in the isolate and in the zone. So if there's an actual problem executing the Flutter framework's run app itself, it'll catch it. Now we've had it stopped right in the app build. Let's go to here. Here is the app state. It is a state object. It's build is now being called right here. There it is. There's its build. It's calling its widgets build, which, as it happens, contains a future builder. It's calling its init state. So let's do that. Here's the mechanism involved in doing a hot reload while you're developing. So it rebuilds your create view, which is your home screen. So the system itself initializes system preferences. Let's just go through that. I shouldn't have done that. Now, we'll have to just go through and find the error. Okay, there's the error. Step out, steps out of there. There's the error. Now, because of that error, it falls out of the init async method, goes into the anonymous builder, passes a snapshot describing the error. We then define the Flutter error details. We go through the possible handlers. We go through this one. And discover that there's nothing being handled. Again, nothing being handled. Fall out of that. It goes to the apps on Async Error handler. Fall through that. It goes into the MVC Patterns Framework handler. It called, of course, Crashlytics. It does its thing. And then finally, the framework does its thing. Get the handler, calls this routine, and displays, in this case, this message. There you go, a quick run through, giving you an idea that this framework does a lot for you. You have got responsibilities as well, of course. You've got to provide error handling. If you don't, you're just going to get the red screen. All right. Talk to you again.